Alrighty. Sweet. Okay.
I haven't done the homework yet.
What?
I haven't done the homework
I did
yet.
it.
You did it?
I didn't write anything.
It's all good. Alright, yeah, we can go over the homework real quick.
I have to restart my computer.
What's up?
So I think I have to restart my computer because it won't connect
That's
to the
okay.
Wi-Fi.
We can start off with the
Stop myself.
that's not good. We're gonna start off with the rotational status part 2, right?
Yeah.
Alright. Because I can't do it all for you.
Yeah.
You can't?
Technically no. I'll do majority of it. Put it that way. Don't worry, there's only like
We have math together. And you
a
have
third
to
of the
do-
class is like done it.
Oh, I forgot.
Only a third, yeah.
Black and white.
Alright.
Because I broke this.
Okay.
It's so dark.
Right.
I don't know, but it was like that the whole last review and
Really?
it's terrible.
Yeah.
I was just looking at the computer screen because I couldn't barely see.
Yeah, just look at the computer screen. Let me see if I can like rotate. No, it's like locked in here, so I can't like. Well,
It's the same.
alright, so. Just kidding, I'm not gonna start that.
It's on my computer.
Whoa, oh, what you talking? That's weird. This is the music problem. This is. This will be the. Change the status.
Oh.
Cool. Alright, so the picture is going to look like these two bars hanging a meter stick. Taking the two strings, hanging a meter stick. So bam! Meter stick is length of L. And it has a mass. It initially hangs from two strings, one at the 25 center mark and one at the 75 center mark. So from here to here is 1/4 L, and here to here is also 1/4 L. So this part is just going to go over 2. Yeah. Does that make sense?
Yeah.
Yeah.
Yeah. You guys can read it.
Since we put the length, but that's cool.
What's up?
So it makes more sense with the length, but that's cool.
Oh,
Because it's like 25 centimeters.
I mean,
But like, yeah, I know.
You can't give away, is it because you can't give
Yeah.
away the answers?
yeah, I can't really write down answers. But
What if
honestly,
you do your numbers?
I mean, I could.
'Cause
But I mean,
that
it
makes
basically
more
boils down to, it just boils down to formulas. Because then once you get
Yeah,
a formula,
but
you
I just feel like I learn better when I see like numbers.
the numbers. Okay, that's fine. Okay, so if one of the numbers, so here are the digits. Alright, so we know the mass, there's only one mass because it's just the meter stick. Meter stick is 0.183 kilograms. This is so blurry. And then we know that the length of it, the whole entire length is 1 meter, right? And yeah.
Then
Yeah, I think that's basically it. Yep, and then, I mean, I guess from here to here is 25 centimeters.
Oh, just like,
Yeah, yeah. That makes sense, because that makes basically 0.25
Yeah.
meters, yeah.
maybe.
Real simple math, that's why I left it like this for you guys. So you guys can like plug and check the numbers if you guys set the numbers. So this is all that is given, and then what's that stuff? So just scroll down a little bit. Right there. Cool. So number one is asking for the tension in the left string. So trying to solve for here, the tension in this string. So, tension and left string. Okay. How do you guys think you guys would go about this?
Do you have Wi-Fi right now?
Yes.
Yes.
Do not?
No.
No.
You think that? Yep. They're like really shitty at connecting to the
Really?
Wi-Fi.
Usually,
Yeah.
this is the first time that's happened.
Oh, really?
Yeah.
Because like I have one and then like two more friends have it. We all have problems with it. So we thought it was good.
ThinkPads.
Yeah.
So you gotta get a MacBook.
True. I got it for graduation though. So
MacBook sucks.
Ew. What's up?
MacBook sucks.
No, they're awesome.
You can never play video games.
Are you kidding me? We play so many video games on here.
It will raw. Japan.
It depends. It depends. Obviously, there are gaming computers out there, but it still works. Anyways, so how do you guys? So do you want to just like write this stuff down? Yeah.
MG over 2.
Well, why?
Yeah, but why?
But
Yeah,
Why is it over two?
Because
I get the
it's
MG.
That is the answer. Okay. Oh my gosh! Literally every single time he comes here, it's just like, oh, I know the answer to this. I'm just like,
Why are you here?
well, how do you derive that? That's what we need to know. Okay, so basically,
This is
you know how we did FAM last time?
Yeah.
Right?
Oh, it's like the other one that's the same but different for
Exactly.
rotational things.
Yeah, so it's a little bit different. So this one, you're always gonna write down the summation of the torques is equal to 0.
So I write this on every single equation like
I mean,
you
you
did.
can if you want.
I actually did that on my exam.
Did you have plus one?
I don't know.
Probably did. I mean, he's like, okay, well, at least you know
She obviously knows.
He's applying for it. Yeah. Yeah, so basically the summation of the torques is going to equal to 0, right? So, basically what you guys are gonna do is, you guys take the whole entire meter stick, and you guys have, let me redraw it. So, this is your meter stick, and you guys have a string that comes down at this point. And this is going to be, what, 0.25 meters. So it's basically equal to L over.
It's the same. but different.
What's up?
It's the same drawing.
Yeah,
Oh.
I just wanted to redraw so you guys can see it.
Okay.
And then you also have like another string that's right here. But because they're asking for the tension right here, the tension in this string, you don't really have to worry about this.
Okay.
Right.
Similar.
So, first of all, you guys get to pick the point of rotation. So you usually choose like the end of it.
Okay.
Right? So I would choose, say right here. This is where it's rotation. Okay. And then right here is the midway point of this whole entire meter stick, right? So here would be L over 2, which is equal to, oh my gosh, 0.5 meter. That is it. What is up with this? Oh my gosh. Okay. Alright. Meters. Okay. So basically you only have to worry about this string and the ruler itself. This guy you don't have to worry about. Okay. So summation of the torques. So I'm using the center of mass and using the torques basically. You guys remember what the formula is?
Is it,
Well, torque, basically.
The inertia times acceleration thing. Angular acceleration.
inertia plus the weight?
So you guys have, okay, so what I would do is basically this right here, this string, right, is trying to pull this whole entire thing up, right? And I'm denoting that this is positive and that is negative,
Okay.
right? So we know that this tension right here is pulling up on the rope at this specific point, right? And right here, because if we just treated the whole entire mass of the ruler, this whole thing wants to come down due to gravity, right? But you notice that this point is not equivalent to this point. So therefore, you have to do some type of summations of torques, which is why we do torque, essentially. So they give you the distance where this is, they give you the distance where that is. So what you're going to do is basically,
Times the mass. And
What's
then
up?
subtract it.
what's that again?
Can you do the distance times the mass and then subtract it?
Oh,
Or the weight?
distance times the, yes, force. Distance times the force, right? So basically from here, you guys know that if you're just dealing with that thing, go back to fan, right? Force equals ma, but in this case, it's force equals mg, right? So right here, if we just deal with, we're just gonna deal with this guy right here. Wait, shit, I do the opposite way. Nah, no, I didn't do the opposite way. Okay, this is good. So we're gonna do right here is gonna be the negative. First, gonna deal with this guy with the meter stick. So it's gonna be what? Negative.
0.5 times the mass times 9.
Which is, but that's basically going. But we're trying to solve for the tension in the left string, right? So it's just gonna be tension. TL, T to L. No. Yes. No.
Wait, why? Why isn't it though? I thought you just told me it was the force times the length or the distance away from the rotation.
Oh shit. Okay. Ooh, I should not say that in the video. They actually took the rotation. They took the rotation from here, which is quite interesting. They took the rotation at here because that is a pivot point at which another string is attached to it.
Oh.
Yeah, that does make sense. My bad.
Okay.
Yes. Yeah. Yes. Okay, this makes a lot more sense now. Okay. Sorry. So the rotation is not going to be there. My bad. Rotation is going to be right there. Reason why is because remember last time we were dealing with the beam and the two little things that are supporting it.
Yeah.
And then we had put like if we put like the mass at like on top of one of the supports. Then the support is like
We want it
yeah.
to be
At the full end, yeah. You want to be at the axis. So, okay, this works out. So, we're just dealing with the beam. What is this distance going to be?
0.25.
Yes. So that's going to be L over 4. That's going to be L over 4, right? But in the negative direction, multiplied by the mg, which is the mass times the gravity. But then we're going to add the upwards portion of the tension, right? So the tension in the left string, but then we just need to know the distance from the rotation. So it's going to be from here to here, which is going to be what?
1.5.
Exactly. So L over 2. And that's all going to equal to 0. So basically just do TL L over 2 is equal to 1/4 mg. Sorry, wait, did I forget where's the
Negative.
L? There we go. Oh, yeah, on the side. So these guys disappear, multiply both sides by 2, get TL is equal to mg over 2.
Wait, sorry, I just missed all of that.
Okay, so
Oh, I see it.
you see it? I'll just really quickly explain it again. So this part is dealing with the torque of the ruler. This is dealing with the torque
The string.
of the string. But notice that this is minus and this is plus because they're going opposite directions. You make the equivalent to each other and you're solving for the tension because that's what they're asking for.
Wait, I know you answered this already probably, but can we talk about the first part of the equation? How do you know,
This part?
why is it TL times the half?
So TL is, what part are you asking about? The TL or the L?
Oh,
Okay, so TL is because we're just
so
solving
like,
for
wait,
each
wait, never mind. I'm asking about the first one now. How is
This one.
that, why is that a torque? Is that like? 'Cause
Well,
it
you know that mg is the force,
yeah,
right? And then
even, so this is like the same as like solving for force?
close, but torque, remember torque, the general form, torque is equal to R cross F,
Okay,
right? So the force in this case is mg, and then the R, the radius, is going to equal this, which is R
okay.
before, which is
And then,
this guy.
so it's the same for the other one, the force is the tension.
Mhm. Exactly. So honestly, like the little addition from what you guys have done before with like force body diagrams is that you're just multiplying it by a radius
Okay.
from a certain point. The key thing is just figuring out at what point you use because I screwed that one up. But yeah, okay.
Oh, okay.
Does that make sense now?
Yeah, that makes more sense.
Okay, so do you guys want me to multiply it out? Or
No,
no.
it's fine.
just you guys? Okay. I kind of just like wrote down the values and I just completely ignored them. Well, the main reason why I didn't want to write down the values is because if I show like this, then you guys can see where the numbers are coming from. Because if I
Yeah.
just wrote down like
Numbers.
2 point something, you guys be like, how'd you guys get 2 point something?
Yeah.
MG, you know, like, yeah. So, cool. So that's number 1. Let me stay the page. Are you guys good? Can I like make it disappear?
Yeah.
Okay, cool. Right. B. Now the string is cut, what is the initial angular acceleration? Oh, the right string is cut. Okay. So the right string is cut, so it's like this. This is the string. This snaps. Yeah. And this guy's gonna be swinging like that. Yep. And this is the point. So this one, what formula would you guys be using?
What are we finding?
The same thing.
Oh, tension.
Angular acceleration.
Oh,
Oh my gosh, this is not too fun. Oh, this is not too bad. Just kidding. Okay. All right. First things first. Where would you guys pick as your axis of rotation?
where you put that?
Where?
The left.
Do you guys do it here, here, or there?
The left string.
This one right here?
Yeah.
Yes. Reason being is because just think about like this is going to be rotating. So that's going to be like rotating that direction, and that is going to be the pivot point. Cool. All right. So again, now this time you don't want to start off with the same equation because they're asking for something different. They're asking for the angular acceleration. So what formula with torque gives you angular acceleration?
Torque equals inertia.
Yeah.
Mm-hmm. So this summation of torques is equal to I alpha. So in this case, you don't really have to worry about the string, right? Because the axis of rotation is at that string. So all you really have to deal with is the meter stick. So what is the torque of the meter stick? Because we said that this was the axis of rotation, but this is the center mass of the ruler. So, oh, and sorry, this is L over 4, and still this whole entire thing is L. So what would that point be from the axis of rotation? The center mass of the ruler from the axis of rotation. That's what I think that's.
Point. L over 4 times. Yeah.
Oh, I'm just asking for the distance. Like, what is
Oh.
what is R? Like, literally, what is this?
Oh.
L over 4. Yeah. Cool. So this is L over 4, and that's the radius. So then, what's the force?
No.
Yeah.
MG.
Just mg. Because again, we're dealing with right here is going to be we basically reduce everything down to a specific point.
Mm-hmm.
So this would be there, which is mg, right? So this,
Oh, because we moved the little spot then.
Mhm.
Got it.
so that's why it's mg.
Okay.
Cool. Awesome. Now this is all going to equal a supermassive large equation.
Really?
Inertia. Now with inertia though, you guys need to use and do what with the equation?
The moment.
With inertia.
MR squared.
Mhm. But because we're dealing with the beam, remember last time that super crazy thing, like when you guys first introduced this to you guys were like ICM plus another thing.
So
You don't remember that? It should be your homework sheet. Do you have a formula sheet?
No.
Oh,
no.
Do you have a formula sheet?
Yeah.
Let's snag it real quick. I can write it down.
ICM plus MD squared.
Yeah, so you have I is equal to I.
Snag.
Yes.
Snag.
Oh, snag. Oh, what is snag?
Snag.
Yeah.
Like you snag?
Yeah.
You
Yeah.
said,
Oh, let me snag this from you? Oh, like let me like take it from you and pull it away from you. Why? Oh. Okay.
It's gonna start using
oh
it
yeah, new vocabulary.
New vocabulary word.
Love physics.
Yes. So you have a rod, right? Let me just write this down. Our rod is equal to 1 over 12.
Did you get that?
It's in the equation.
It's in the equation sheet.
Oh.
1/12 ml squared. Yes? Yes. Sweet. Okay, basically you just follow this. Wow, literally you just follow this. Okay.
What's M?
So then
M is just
times-
mass.
Oh.
And then L is just 1, and then plus from the center, right? So then the mass times
Oh.
what you call it? Mass times L over 4 squared.
Hey, look at you.
See, like I can't remember from. It's been a while.
You got it. And then
And then we just solve for L.
exactly what you do. Awesome. Does that make sense?
Mm-hmm.
Yes, kind of.
I
Maybe
can't
some.
wait, no. The second part?
This part?
Yeah, is
Do you wanna
that
explain
the
that?
angular sum?
What's up? What?
No. So this,
Oh, okay.
this part is for this part.
Oh, it's,
Yeah.
okay.
And then this part here is for this part. Here, you want to explain this real quick?
The
How you got L over 4, basically.
L over 4, that's the distance from the center of mass to the axis of rotation.
Oh,
Here to there.
for the
For the ruler.
D.
Yeah, so D, don't get mixed up D with diameter. D is just distance.
Oh,
So D is just the distance between these 2 points.
okay.
Right. So basically from there, and then you do some algebra, not too difficult. Just double check yourself though towards the end.
Mhm.
But basically, you guys should get that alpha is going to equal.
What does ICM mean?
What's up?
Center.
Should be that. All right, just to recap, angular acceleration or solve for this, usually we have to deal with some
Is
type
that
of, what's up?
over 7 now? Or?
7,
Oh. Okay.
I just
I
like,
was trying.
I mean, if you want me to do the super long,
No,
we
no,
can,
no.
but.
I wrote down the super long way and I was trying to figure out where the sun was.
Oh.
But, yeah, I see what you mean.
Got it? You good? Sure? Okay, so again, recap, angular acceleration, the problem states that the right string snaps. So the axis of rotation, the easiest axis of rotation is going to be at that specific point where it's still attached, right? So where the left string is. We know where the center of mass of the whole entire ruler is. So in order to solve for angular acceleration, we have to use torque with terms with angular acceleration because that's basically what we're trying to solve for. Torque, again, r cross f. Radius, the torque that we're specifically looking for is we're looking at the thing that's moving, which is going to be the meter stick. So the torque itself is going to be r cross f. R is going to be the center of mass distance from the axis of rotation, which is going to be L over 4. That's the R. The force is just mg because it's, it's just the force. F equals ma. Now your inertia, though, is where it comes to the hard part, or the semi-hard part, is basically you have to understand that because the center of mass is not at the axis of rotation, you have to include this extra term of md squared. D, again, stands for the distance from the center of mass to the axis of rotation. And then m is just mass. Like there's no difference between that m and that m. Cool. And then L in this case, this whole entire term though, ICM should be just given to you in your table. You just have to decipher what physical thing is this thing. It could be rod, it could be a cylinder, it could be.
And they're not gonna give you anything that's not on there?
No, there's no way.
Is there a way to figure that out?
I think there should be, but you'd have to do like experiments.
Oh.
Yeah, but you guys are not doing lab during the tests.
Yeah.
Who'd you have for physics 2?
Who did I have? Spinzoris.
I don't know.
Yeah, I had Spinzoris. She was really good, except honestly, it was the exact same issue with Physics 1, is that not many people liked going to the class, and then eventually like slowly died out. But I've personally found Physics 2 easier than Physics 1, which is strange.
People say it's like all theory and it's
There is theory, and it does take up a lot of your test, because it's like if you miss a question, like a multiple choice question, that's 5% of your points.
Is that more like circuit stuff?
They do have circuit stuff because they have like magnetism, like magnetic fields and stuff like that. So they have a little bit, but not fully. There was like a huge unit that was on it.
Because I took physics in high school, and that's like all it was. It was like.
I mean, there's a lot of that, but I mean, obviously, like once you hit college, they go into so much more depth.
Yeah.
So even with generals. But yeah. You guys do need physics 2 help when you guys are like next year. Are you staying here? Or you said that you're transferring? I don't remember that.
Yeah, maybe. I don't know.
Maybe not. Okay, but if you guys do need help, you guys can reach out to me. I do have all my physics 2 stuff. Like I also took lab too, so if you guys are taking lab, well, I know you have to take lab, so. But yeah. Okay. Anyways, we digress. Yeah. So inertia, you guys understand all that. Tachyon alpha, which is what you're solving for. Simple algebra, solve your equation. Full bam. Type in your stuff, and you're good. Do you guys have any questions about it? No. Okay. Let me stun the page one more time. Cool. All right. So number G. This one is asking for the tension in the left string right after the right string is cut. Okay, so tension in left string after, wait, right after right strings, yes. Wow, you guys know that says right.
Yeah.
Okay. Alright, so basically, this is what it looks like again, that this guy snapped, and now they're asking for the tension, and this guy's still going like that routine. But like, it's like instantaneous, so. Okay. Any ideas on how to do this guy?
Well, my question is, where do we put the axis of rotation like all the way to the left now? Or do you still keep it at where the string is holding?
I'm pretty sure you still keep it where the string is holding, which will be right here. That's a good question. Yes. So I'm pretty sure you're right there. So this is your axis of rotation. That's your center of mass. This is still L. Mass is still the same. Everything's the same. Yeah, so your axis of rotation is still going to be here because, I mean, you can do it there, but it's going to be, there's just more like computation stuff.
Okay.
This just is a lot more simple because it just rules out that string alone. Okay, but the thing to keep in note about this one is that it's asking for a force. Okay, so they're asking for the tension. So in this case, you guys want to go back to your first exam on how you guys solved it, which is what?
Can.
Yep, cool.
Like anything I discussed.
F equals ma, cool. So the sum of the forces is equal to mass times acceleration, right? So how would you guys begin to do this guy? So what things do you guys have? Like if you guys were to draw the force body diagram on this, what would it be? Right here, down, mg, and what else?
Oh, no.
Which is what?
Tension.
Exactly. Yes, this would be tension, because that's what you guys are solving for. Sweet.
But we're not doing the little diameter radius thing?
What's up?
Because we're doing sum of forces, so we're not multiplying it by the distance.
You can do it with torque, but that just makes it super long and more complicated. And we can still solve it that way too if you want.
No,
But okay. So solving it with force equals ma, we know that.
You know the mass of it?
What's up?
Oh, wait, no.
So basically, we're just gonna go straight into this. So the summation of forces is gonna equal to what?
0.
No,
No?
because but no, it's not going to equal 0. Sorry.
Oh. Is it?
Reason being is because they're not at the same point. If you guys were to draw this tension mg, then summation of the forces would equal to 0. So then you can say that T1 is equal to mg. Remember that?
Yes, but it's not that.
But that is assuming that these two forces are acting at the same point. They're not acting at the same point there. So you need to use okay. So that's a good question. So one of the forces, what would it be?
One of the forces.
One of the forces, right?
For tension.
Yeah, so you have force tension. I mean, so basically you have F of G, but then tension is the opposite, so tension in the left string. And that's going to equal MA,
Oh.
right?
So I gotta go have fun.
Oh, why are you leaving?
I had some other things to do. Very much.
Okay.
No.
Sounds good. I mean, he already understands all this stuff, so I think he's good. I think he's fine. All right, so yeah. Now, we don't know what the acceleration is, but we do know something else.
Wait, what's
The
that?
angle. Sorry.
Wait, what's FG? Sorry, what?
Force of gravity.
Oh.
Remember, this is from the first unit.
What?
This is from the first unit.
So it's just 9.81.
Well, gravity is 9.81, but force of gravity is mg.
Oh, okay.
Yeah.
Why don't you just
So
write
that's
MG?
just,
Can you just write MG? No.
sure.
Okay.
Now, wait, what did you just say before though?
Did I say something?
Yes.
Oh, angular acceleration.
Yes, we have
Is
the
it
A,
the same?
because we don't have A. A is linear acceleration, but we know a linear acceleration in terms of, or like, with A in respects to angular acceleration. So what is the,
A equals R times angular acceleration.
oh my gosh, right? Yes, equals to R times angular acceleration. Cool. So, in this case, what is R going to equal?
And acceleration divided by.
Oh, no. What is R? Like, R is the
Oh.
known value that you can solve for. Like, R in this case is going
Is
to
it
be,
L over
0.25. Or L
yeah,
over 4.
it's going to be this guy right here.
But R is usually the radius, so like in this case, is it just the distance from the center mass to, okay.
Okay.
Radius, distance, they basically all mean the same thing.
But not when it
Yeah.
comes to the ICM plus.
Yeah,
MD.
when it comes to that, then it's,
Yeah. Okay.
Alright, so yeah, this radius is just gonna be L over 4, yes. Cool. And then we already know what alpha is, so we can solve for A. But in this sense, I'm just going to, put it into it that way. So mg minus TL is equal to m times the radius, which is L over 4 times alpha. Cool. So we have, everything checks out. We have M, we have G, we're solving for
Yeah.
this. We have that, and we just solved for alpha. Right? So, if you guys boil this down, TL is going to, oh my gosh. TL is going to equal 4 over 7 mg. Interesting.
Yeah.
Honestly, you can either solve it that way, they reduce it a lot more, or you guys can just literally plug that all in, subtract that from that, and then take the opposite. Basically, same idea. Same thing, which you guys can, just plug and chug and just get that. Coolio. Is there another problem?
Oh yeah. There's one.
Oh my gosh. Oh my gosh. Okay. All right. It's all good. Okay, so right after the string is cut, the meter stick swings down to where it is vertical for an instant before it swings back up in the other direction. Okay. So visually, it looks like that. This string is already broke. This is swinging down. And then the string and this guy. And then the third image, it like swings up to that point. Right? Does that make any sense to you? It's like
Yeah.
like that.
Yeah.
Can't really like describe it, but that's kind of like my pictures of what I see. All right, so they're asking, what is the angular speed when the meter stick is vertical? So D is asking, when,
You were using numbers before.
still want me to use numbers?
No, it's fine. Like 1, 2, 3, D.
What?
Like.
Oh! No! Wait, what just said
I don't know.
There you go. Because I'm looking at this one that says D, so I was like, oh, okay. But then I looked back and I was like, it says 4. Anyways, all right. How do you guys think you guys can solve this guy?
do we find angular acceleration and then get the angular speed? Or is it like separate?
You can do that. That's gonna
It's
take a
just
lot more
harder.
steps.
Of course.
Yes. Um, all right. So this is where you guys are gonna do the conservation of energy. If you guys remember that.
1/2 energies.
Close. Yeah. No, that's really close. It's interesting. Why the heck did I do it that way?
So we're using 1/2 I.
Oh.
We can't use that.
So they use the initial stored energy to when it becomes final, when it's completely vertical, which is the kinetic. Yeah, that's clever. Okay, so EI is equal to EF, right? Yep. But we know that initially, which is this guy, this is center mass, yeah. This is going to be potential energy, right? And then once it gets to this point, right here, is going to be kinetic energy. So because it's going to be moving.
GH equals
Wait, say again?
MGH equals.
No? Close. MG is correct, but the H is not necessarily correct. The reason being is because we're not just taking meter seconds dropping it.
Well, but like it goes from here and it's 1 meter.
Yes, but it rotates. So when you deal with something that's rotating, what do you use? No, I'm looking for a word that starts with T. Yes, you're using anti-torque. Okay, so you would be technically correct if it was just an object falling, like directly just straight down, you know? But the fact that this is rotating, it's a little bit different. That's why you have to always resort back to torque if there's some type of rotation. Okay, so we know that initially, what was the torque equation that we used? And this is a really poor representation, but again, this is still L, and then right here is what? Because you have to figure out what R is. What is R? It's basically the same R that we've been using.
Oh, we just keep using the one from the rotation.
Keep using it from here, which is our axis of rotation. So what is right from here to here, from the center of mass to the axis of rotation? Yep. So we know that mg L/4, right? So that's what's initial. That's what's starting there.
So it's like MGD.
Yeah.
Okay. All right. Cool.
And then final, because it's kinetic, this is how we can figure out our angular speed. So what, with rotation, what formula can give us angular speed?
Rotational.
What formula can help us figure that out?
In the 1/2 R omega squared. It's omega, right?
1/2 what?
1/2 I.
Yes.
Omega squared.
Yes.
Did I
This is
say
the one-
L?
You said R.
Oh.
I was like, what? But yeah, 1/2 I omega squared. And omega squared is what you're solving for. Right?
Just.
1/2. Yeah, it's 1/12.
Yeah, so this one gets a little crazy. I don't
It's
understand.
not that easy. It's not just 1/12.
Yeah, the I, and wait, what did they do? Did we solve it before? No.
No.
Make sure we can figure it out. So what they do is that they did inertia is equal to, so 1/2 over 12. Oh, this is funky how they did it. Do you guys want me to write it down and see if we can try to figure it out?
Sure.
You guys are gonna be like, what? And I'm honestly right now, I was like, what? So they basically said that inertia. Yeah. Apparently that's what inertia is going to be.
7/48. Wow.
Yeah, that's what I'm trying to figure out how the heck did they get 7/48.
Got the 24 for 1/29 on that.
This is a moment of inertia. Due to the prime. Center mass is going to be rotating downwards. So.
We don't need translational because it's not spinning.
What's up?
You don't need translational.
Are you just trying to solve this for what this time?
What's up?
Are you just solving this for?
We're trying to figure out how the hell it's 7/48. Right plus another guy. Oh, I
How do you
think-
know it's 7/48?
Yes. That's what I have in my answer key.
1/12 times where, like,
Because 1/12, if you do
times 1/4.
it's 48, but then how the hell did you get 7? Right?
Yeah.
7 is where it's a little bit confusing. Anyways. You guys
There's
want
no
to
sevens in the previous one.
yeah. Is this can't be the if you were to wait, what happens if you were to do that? If you just took the no, because that's specific to the inertia itself. Inertia is yeah, it's 1/4. I have no idea. So we change it to okay. Anyways, that's what it is. This one I'm like
It's equal to MG.
yeah. This one I'm super lost about. That one's still the same. It's literally just this that I'm slightly confused about. But anyways, simple algebra because you have that, you have that, you have that, and you have that. Just omega. Solve for angular speed, not squared version of it. It's basically just going to equal. I was just added to an organization called Society of Asian Engineers. Interested. Probably just
Are you an
started.
engineer?
I'm a BME, I'm not a medical engineer yet. 24G divided by 7L.
Square root of it all.
Somehow.
Yeah, that one I can't really tell you. That one I really honestly can't tell you. I don't. That one I will have to fully admit. I don't know what to do. Makes no sense. But the next ones I know how to do. Those ones, they seem like like pretty straightforward.
The acceleration of the center of mass.
Acceleration of the center mass of the meter stick when it is vertical.
Can we use the omega we just got, right?
Yep.
And then we put that into
Around that track.
Wait, are we on number 5?
Yes, we're number 5.
We just put those into one of the rotations and it's done, right?
So yeah. It's literally just one super easy formula.
It's not the
Acceleration of center mass of the meter stick when it is vertical. Thing about this is, wait, trap for 0 with hint about centripetal. What? This is 5, right? And what is the, oh. Yes, so there is no angular acceleration, but there is a centripetal acceleration. So.
Oh, it's, so you use the V equals R times omega, right? And then,
You can do that, but it's an easier equation.
well,
Directly with acceleration, angular acceleration, or not, sorry, linear acceleration. Should be a formula that's in there.
we talked about the rotational kinetics stuff. One of those equations? No. One of these up here.
No.
Because you can't use, because there's T involved, or,
Well, technically, yeah. Yeah. Yes, you're really close. Yes. Yes, use those equations.
but why?
Okay. So so basically you need to solve for that, right? Solve for it.
Yeah.
Right. And you know that A is equal to what? The radius times the angular acceleration, right? Hmm. They should have wrote this down in here for you guys. Would have been a lot easier.
No.
I just give you the formula instead of you guys have to derive it from these formulas.
Is it like always like that?
This is
Oh,
already
you
in
mean that? No,
Yeah.
I mean,
the formula that I'm about to give you guys.
yeah. Is it like always the same or is it like?
Yeah, it's always gonna be the same. So the new formula that you guys need to write down, or like it's super helpful, is that the linear, or I mean you can write AC. I did in here, I swear to God, I totally swear I saw it in here. Oh my gosh, it is!
No.
So it's not, okay, so rotational kinematics, we can't use that because we just described that there's no angular.
Yeah.
Right? So go to uniform circular motion, and you're good. So yeah, it's not really
Oh.
JK.
I never even noticed that.
So what is it?
So A equals omega squared times R.
Yep. And we have omega squared, and we know that R is just going to be the distance from the center of mass to the axis of rotation again. It's the same R that we've been using. Right. So if we were to basically take that, we know that the acceleration is essentially going to equal to
Why do you keep writing AC?
centripetal
Oh.
acceleration.
And can you use A to get the force of the string when it's vertical? That would be the next question. Using
Yep, that's exactly how you do it. Alright, so, well, as we move on, this is number 5. Pretty straightforward, cool, awesome. Just remember that, do you guys understand why it's centripetal though?
Yeah.
Literally rotating in a circle, yeah, so that's why it's centripetal. Alright, so number 6 is asking, what is the tension in the string when the meter, no, yes? Yes. What is the tension in the string when the meter stick is vertical?
That's what I just asked you.
Yes.
Okay. Just making sure.
When the string is vertical, my handwriting sucks.
String is vertical?
Wow, I'm just word vomiting.
I was like, cool. I already answered this.
Oh my god. Okay, when the stop. Okay, yes, when the stick. When the stick is vertical. What is going on with this computer right now?
Maybe really cool.
Like, do you see this? Oh, no, it's good. Okay.
Okay.
Sometimes like I write here and I'm like right down here. It's weird.
Because you like accidentally tap it.
Yeah, something like that. I don't know. But anyways, it's basically this is your string. I'll draw the meter stick with all
Lots
the
of pictures, I like it.
What's that?
Lots of pictures, I like it.
Yes, I'm a visual learner. Visuals help so much. I hate when professors just explain stuff and I'm like, I know there's a
What?
picture. Just
There's always a
draw it.
picture.
There's always a picture, especially in engineering. Come on. Anyways, so yeah, basically this idea. Unit 1, what we start with, because we're dealing with another force again, right? So we have to start off with.
Damn.
Yep. Summation of the forces equals MA. Right?
We just found A.
Yes, but hold your horses.
Oh.
This is asking for the tension in the string. So there's this tension here, right? And then there is this mg, and there's also this tension. Okay, so I'm gonna write this down. Force of tension minus, because it's going the opposite direction, force of gravity is equal to ma. Reason why we keep ma, why?
It's not zero.
Yeah, I mean, I guess,
That was
yeah.
my guess.
I mean, there's that, but it's also because, remember, the center of mass is like, how do I just, this and here, this is like the center of mass of the stick, and then this is where it's still rotating, right?
Yeah.
So because these 2 points are not the same, you can't assume that it's equal to 0. Only at which, if it's at the same point, then you guys can. But in this case, it's like this, right? So it's a little bit different. So you have to keep MA there. So just rearrange this whole entire equation, because you need to solve for this guy, right? We're just trying to find tension straight. So we know that F of T is equal to MA plus F of G. And this is just a comment. So we know that F of G is equal to mg, right?
Oh, this was on our quiz.
Oh, what's it?
Now that I'm thinking about it, this looks really fun.
Okay. So issue, we have A. What is A?
We just found it.
Yes, exactly. So it's 6/7 G. So 6/7 G M plus G. So bam, and you're done.
Wait, there's 6/7 G?
I think so. Whoa. Whoa.
What?
We're 5.
I thought it was 20,
Yeah, I thought it was
24.
Oh my gosh.
Close.
Oh, my bad, because we didn't fully multiply out the radius. I just assumed that the radius was known. Because this is 24G over.
Oh.
24G over 7L. And then radius is the distance, right?
Oh, yeah.
Between
Yeah.
the two. So then we have to take L over 4.
Oh,
Right.
Gotcha.
And then L's cancel out, so 6 over 7G.
There we go.
Cool. I didn't mess that one up this time. So yeah, so that's how we get this guy right here. And then if you really want to,
Like
you
take
guys
that
can,
energy out.
no, you cannot take MG out.
I know.
Because you're solving for,
I know, but you can like take it out and put the other things in parentheses.
well, yeah,
Make it look
essentially.
nicer.
Essentially, yeah. If you want to make it look nicer, it's basically going to boil down to this. Basically the same idea that you just said.
Yeah.
And there we go. That's your answer. And that was exactly 9 p.m. Oh my gosh.
Damn.
That was
Is that all of them?
like literally right on the dot. That was hilarious.
Wow.
There is a few more that are like the, oh no, this is the last one. So where is the angular acceleration of the meter stick at its maximum?
Maximum what?
Angular acceleration.
Oh.
gonna go with. I feel like the
At
tension
the end?
increases as it drops.
Yeah.
So it's vertical. It's not that. It's the opposite.
Wait, the option is right after the string is cut from the meter stick is still horizontal. When the meter stick is vertical, so at the bottom of its path, or the angular acceleration is constant.
Bottom.
So it's either bottom, top, or they're both the same. Give me an answer and explanation, and then you guys are free to go.
So
I was gonna
wrong
guess
then?
it.
What's up?
Mine was wrong.
Not bottom.
You guys both said it was the bottom. You guys would be correct if this was centripetal acceleration.
Okay.
I mean, you guys have one two options now. It's either consistent or it's from the top.
Horizontal. But
Yeah,
that's
it
what
is from the top,
Okay.
right when it's cut.
I don't think so. You got the wrong one.
Oh, because it still has like more distance to go. Gravity or something.
It's more potential energy.
That's what I believe, yeah. The torque, so this the torque on the meter stick is a maximum right after the string is cut.
Okay.
Cool.
Yeah. So I guess think of the opposite. Angular acceleration is the opposite of, oh no, yeah, angular acceleration is the opposite of centripetal acceleration. So wherever centripetal acceleration is least, that is where the angular acceleration is the most. Coolio.
Are we doing this same time? Could we do like a longer one?
I could try to. What am I doing Thursday?
Just because it's like the last one that we're using.
Do a longer one.
I don't know, but I don't think I can because I have an alumni meeting.
What?
Oh, I thought you meant like legally or.
Oh, no, I mean, I could. I mean, I've done that before with chemistry. Because, like, but except that was with, like, 20
Bunch of
plus
people.
people.
Maybe.
But the last one, there's always at least like 6 people.
True. But anyways, yeah, if you guys, well, there's a guy that comes before me.
Oh, yeah.
Oh yeah,
I don't know. if
John
that-
Hirsch.
Yeah.
Everybody's reviews, there's the same thing.
Yeah,
Yeah,
so you
he's
can go to
like-
his reviews starting at 4:30 to 5:30, and then I take over from.
Actually, I
5:30
think
to
these are after you went through 6.
No, he's before me.
Oh, it is?
Wait, unless he's before me. Was he
He's before you
me?
today.
Then yeah, it might be. It
I
might be.
think he's after you, yeah.
Andrew.
Might be.
Yeah,
Is another
Andrew-
one after this?
No.
Today?
Oh, my roommate, Chem
Oh,
125.
Yeah.
oh, that's a late one.
Oh, yeah, that was at it. So I. So the other one.
Okay, thank you.
Yeah, no problem. See you.
What's your thingy?
What's up? Oh, my sheet.
Any,
Yeah.
advice on who to take for classes next year? Because I was in PHYS starting.
Oh.
I'm trying to